Well, we're ready to do homework 2.2c, and we're going to go about it very similarly to how we did 2.2b, starting with, again, copying the prior homework, 2.2b, to form a new file called 2.2c.m, your MATLAB file. Okay, step one is going to be creating a row index array. So now you're allowed to add one more array. Give it a nice name so that it's clearly an indexed list. Call it link or index or something like that. And then fill it with numbers from 1 to n. Then you're going to go back to the logic you used in 2.2b, which is already sitting there in 2.2c because you copied it, to find the rows to be swapped. So the logic is the same. So to do that, we are using our scaled partial pivoting to find the rows to be swapped. But we're not swapping them at all. What you're going to do is, instead of swapping the rows, you're going to exchange row indices that correspond to the same locations as the row. We'll talk more about that in a bit. You're still going to use the a2.xl file, so you better get the same result when you're done. And you still need to print things out. You want to use the same matrices and vectors that you printed out in 2.2b, but I want you to do it twice. First, take the A matrix when you're all done and print it out as it is, just the normal way that you would print out a matrix. Then print it out again, but use your new linked list in the row index position. So continue to print out your solution, calculate the norm, and take a hard look at that to make sure that you don't have to do something a little different in calculating your norm, and then do all the normal commenting and indenting that we always do for the code. So that's the homework. Now let's take a little closer look at some hints on how to put that together. Okay, so again, step one, you're literally creating a new version of the MATLAB code. Then look for where you're doing row exchanges in your logic. There should be two locations. One where you're exchanging the rows of A, and the other one is when you're exchanging values of B corresponding to the same rows that you exchanged in A. You're going to take that code out. Instead, you're going to have this linked list that you're going to create, and this linked list will be initialized as soon as you read the data in. Before you do any logic, you're going to initialize your linked list array from 1 to n. Remember, it's a single dimensioned array. It is not a doubly dimensioned array. So you just assign number 1 to position 1, number 2 to position 2, and so forth. Okay, you still go through and identify your new pivot rows exactly as you did in homework 2.2b. Remember, that was using the scaled partial pivoting. But don't do the row exchanges. Just find out where they're supposed to be. And what we'll do instead is we are going to exchange the row indexes instead of exchanging the actual data. So your logic for exchanging has to be the same. You're still going to use a temporary variable to store some value, and then you're going to clobber that position with a new value somewhere else in this linked list, and then you'll use your saved value to preserve it in the place that you pulled the old one out. So let's be specific. Let's say you were trying to exchange row 1 with row 3. In 2.2, you went through value by value across the whole row and exchanged every value between row 1 and row 3. You also exchanged the B values that corresponds to row 1 and row 3. That code will need to actually go away. You'll have to pull it out. And then in an appropriate place in your script, you're going to have to think about that, you will do the same kind of exchanging, except you will need to exchange the values of the index. So again, back to our example of exchanging row 1 with row 3, you would take the first position of your index array and you would save it somewhere in a temporary variable. Let's call it t. Then you would take the third position of this index value, take its value, and move it to 1. So you're clobbering the first position with the third position. But you saved that first position in this variable t, and you take it and put it into the third position of your index array. So that logic is exactly the same as what you did with row exchanges. The big difference is, instead of changing every single value across the whole array and also changing the b value, you're just doing this exchange once through this linked list. So you didn't move anything on this A matrix or on the B vector. You simply changed the address of where you can find it. So you're going to have to be a little careful now of how you do the rest of the logic in the code. The logic itself doesn't really change, but what does change is how you access the data. So every time you reference a row, where before you may have just called it like A of ij, now it has to be A of the index of I and j. J never gets messed with, but the rows do. So you'll have to change your indexing to be just slightly more complicated, to be referencing the index of the position rather than the position directly. So that means when you're printing this thing out, you are going to print it one way with just like you always did, print out A of ij and see what it looks like, and B of I, and then print out the same matrix with A of index of I, comma j, and see how much difference that actually makes. When you're all done, I'll send you a PDF solution. That's what it'll be called there, and you can compare it with yours. So give it your best shot, and look forward to seeing you next time.